Hey, here we go with lesson 3 of week 15, the third method for solving a system, elimination. So what is elimination? All it means is to get rid of something. So if I have 6 of something and I take those 6 away, I've eliminated it. I have 0 left. That's what we're doing here. Seems pretty simple, right? Let me show you how. All right, so we've been dealing with this problem all week. You know the answer. I'm going to show you how you're going to get the same answer using a different method. So choose one variable to eliminate. Okay. Have a strategy with this. So if you look at these two, right now, nothing gets eliminated. You'll see what I mean here in a second. Okay. These two y's, if I add those together, that gives me 6y. If I add these two x's together, I get 9x. So 9x plus 6y, if I would add these two equations together. That's not good. What do I want to do? I want to make one of those variables go away. So how do I do that? I have to multiply this top equation. I'll just choose by -5. When I do that, it's going to change the equation. Second equation doesn't get changed. So let's see what happens. -5 times x equals -5x. -5 times y is -5y. And -5 times 95 is -475. Is it okay to do that? Yeah, as long as you multiply both sides of the equation by the same number, you can do that to any equation. The bottom equation didn't change, so it's going to stay the same. Now, I'm going to add the two equations together and watch what happens. Okay, this is going to give one variable here. So -5x plus 8x gives me 3x. -5y plus 5y, -5 plus 5 is 0. The y's got eliminated. That's where the name elimination comes from. To finish the problem up, I'm going to do -475 plus 640. That gives me 195. 195, it's a very simple equation now. Divide by 3, you get x equals 55. So we're almost done with the problem, but we have to, of course, use that solution that we just found to find the other variable. So plug it in. Okay, so I'll go with the easier equation, x plus y equals 95. I know that x is 55, so y is 40. And again, like I always recommend, check the solution. Okay, so you can see that down here at the bottom. X plus y is 95. 55 plus 40 is 95. It works. 8 times 55 plus 5 times 40 is 440 plus 200, which is 640, and it works. Okay, that's what we do for elimination. Let's do another example. This one's a little easier than the last one because if I add these together, the y's cancel right away. Okay, so add these together. 2x plus 5x equals 7x. 6y and -6y makes 0. 20 plus 8, got to remember to add those as well. Excuse me. 20 plus 8 is 28. Divide by 7, I get x equals 4. 2x plus 6y equals 20. I'm going to use that equation, and I just solve for x, so I can put 4 in for x. 2 times 4 is 8. 8 plus 6y equals 20. Subtract 8. Divide by 6. I get y equals 2. So my solution, or where they cross, is the 0.42. You can check it, like always. 2 times 4 plus 6 times 2. That's 8 plus 12, which is 20, which is good. 5 times 4 minus 6 times 2. So 5 times 4 is 20. 6 times 2 is 12. 20 minus 12 is 8. They both check out. This one's a little more difficult because if I add these, nothing's going to be eliminated. 4 plus 7 is 11. 2 plus -3 is -1. Now, I've been eliminating the y in all of these examples. That doesn't have to happen. You could actually eliminate the x's too. This case, the y is the better one to eliminate, and I'm going to show you why. But you could also eliminate x. Now, to get these matched up, I see that 3 times 2 gives me 6. And I see that 2 times -3 gives me -6. And if I can get 6y and -6y, I know that those are going to add to 0. So I'm going to do that. I'm going to multiply the top equation by 3 and the bottom equation by 2. So 3 times 4x is 12x plus 6y. 3 times 4 is 12 at the end. 2 times 7x is 14x. 2 times -3y is -6y. And 2 times 33, got to remember to multiply that as well, is 66. Now these y's are ready to be eliminated. So I'm going to add the equations. 12 plus 14 is 26, x. The y's eliminate. 12 plus 66 is 78. Divide by 26, I get x equals 3. I'm going to plug that 3 back into, let's just say, the first equation. You could do the second. It would not matter. 4 times 3 is 12 plus 2y. Divide or subtract 12. I get 2y equals -8, y equals -4. So this solution would be 3, -4. Again, you can check it. Go through this kind of quickly. Plug the numbers in. 7 times 3 minus 3 times -4. -3 times -4 is +12. So 21 plus 12 is 33. And we use the first equation. Go back a slide. We use the first equation here in green. So we already know it's going to work there. We want to check it with the other one that we didn't use. All right, quick summary. We've talked about this for 3 lessons now. A system could have one solution, a system could have no solutions, and a system could have infinitely many solutions. All right, I'm going to use my writing tool to show you how this looks algebraically with elimination. So let's say we have -2x plus 4y equals 10. And then I have x minus 2y equals 8. Okay, I'm going to multiply this bottom equation by 2 to get things matched up. It's going to give me 2x minus 4y equals 16. Nothing changed on the first one, so I'm going to rewrite it to make things line up. I'm going to add the equations together. -2x plus 2x is 0. 4y plus -4y is also 0. So if I'm looking at an equation, I have nothing left on the left-hand side. Now it all comes down to the right-hand side. 10 plus 16 is 26. Does 0 equal 26? No, it's not true. So what does that mean? It means no solutions. Okay, so if the remaining numbers are not equal, it means no solutions. Now, what happens if I change this number right here to 8? This 8 right here. Oops. Okay. What's going to happen is let's change it to, let's say, -5. So when I multiply the second equation by 2, I'm going to get, at the end here, I'm going to get -10. And then when I'm adding those, 10 plus -10 would give me 0. This one is true, and therefore it would have infinitely many solutions and be the same line. And that concludes lesson 3. At this point, you should be getting ready for your assessment. Good luck.